So, let's talk about something that is pretty much the hidden architecture of our entire modern lives: software engineering. When you hear that phrase, you might just picture someone typing lines of code, but it is so much more than that. It's the rigorous discipline that takes a brilliant idea and turns it into technology that can actually change the world.
Just think about your day for a second. It might kick off when you book a cab with a single tap on your phone.
Or maybe later, when you're hungry and you order some food that just magically shows up right at your door. And then think about the big stuff, like banks, which are juggling millions of transactions every single second, all to keep our money safe. And even when we're pushing the absolute boundaries of what's possible, launching rockets deep into space. So what's the common thread here? What's the one thing that connects all of this? Well, every single one of those examples is made possible by the discipline of software engineering. It's the invisible engine that's driving our world. Okay, so what is it exactly? Well, let me tell you, it is not just about writing code. It's a formal, disciplined approach to actually architecting the digital world that's all around us. And that's the huge difference between just being a coder and being an engineer who builds systems that last. So here's the formal definition. It's the systematic, disciplined, and professional way of designing, developing, testing, deploying, and maintaining software. Now, those two words, systematic and disciplined, they are really important. They're not there by accident. See, this whole field was born out of what they called a software crisis, way back in the 1960s, when huge projects were just failing under their own complexity. So this field was created to build things that last, not just things that work for a minute. And this whole process, it has some really clear goals. The software we build has to be reliable. I mean, it can't just crash on you. It needs to be efficient with computer resources, totally secure with our data, and, of course, it has to be intuitive and easy for us to actually use. You could really boil it all down to this. Software engineering is the bridge that turns a promising idea into actual working software that solves real-world problems. It's all about practical, durable applications. All right, let's see how this discipline works in a really high-stakes environment. Because when the risks are incredibly high, rigorous engineering isn't just a nice-to-have, it becomes absolutely non-negotiable. For instance, just think about self-driving cars. This isn't some simple app. We're talking about incredibly complex software that is making life-or-death decisions in real time about roads, obstacles, and, people. In a situation like that, one small software error can literally cost lives. And this is precisely why that engineering discipline is so critical. There is just zero room for error. This kind of risk really brings us to the core reason this entire field exists in the first place: to manage complexity and prevent what you could call digital chaos, especially as our reliance on software grows every single day. I mean, think about it. Modern software systems are vast and incredibly complex. They're often used by millions, sometimes billions of people. They have to work reliably, stay secure, perform under immense pressure, and then be maintained for years and years. You just can't wing it with something like that. The difference is, well, it's night and day. With engineering, you get software that's reliable, secure, and maintainable. Without it, you get unreliable, unsafe systems that are basically impossible to fix. It's like the difference between a solid, well-built bridge and a rickety rope swing over a canyon. Which one would you trust? So, how does this whole structured approach actually work in practice? Let's follow the journey of how a simple idea becomes a robust piece of software. Okay, so the process is methodical for a very good reason. It doesn't start with code. Nope, it starts with deeply understanding the problem you're trying to solve and then gathering all the requirements. Why? Well, you wouldn't build a house without a blueprint, right? Only after all that do engineers actually design the system's architecture. Notice how writing the code comes way later in the process? After that, you've got rigorous testing to find every possible bug, then deploying it carefully to users, and finally, the really crucial long-term work of maintenance and improvement. Every step builds on the last one, making sure you get quality and preventing that chaos we were talking about. And this process isn't just about the technology we have today. It's the foundation for everything that's coming next. The future, without a single doubt, is being engineered as we speak. So, it's really no surprise that software engineering has become one of the most vital and in-demand fields on the entire planet. This is where the big ideas for our future are being built, right now.
And its reach is just staggering. We're talking about everything from artificial intelligence and space tech to the video games we play, to banking, to education and business automation. All of it is built on the core principles of software engineering.
It really all comes down to a simple but incredibly profound truth. Wherever you find technology, you will find software engineering making it all possible. It's the fundamental building block.
And that leaves us with one final thought, really. As you look at all the technologies that are shaping our world, if you've ever dreamt of being the one who builds what comes next, well, could this structured, creative, and powerful discipline be your journey?